All right, guys, welcome back. We are getting ready to learn a little bit about the skeletal system, and my first lecture here is going to be on the functions of the skeletal system. And so this is 6.1 in the Open Stax textbook. Basically, we can boil down the skeletal system's functions to four main items, including the protection of internal organs. The skull the cranium is just a great example of that. If you think about the delicate nature of your brain and the value of your brain to your life, then obviously protecting it from trauma is super important, and that's of course one of the major roles of the cranium is to cover the brain and provide it protection. But I'm going to give you another example in a moment. Also support and movement, and so if you think about this carefully, your ability to stand upright, or for that matter, even to sit upright, I mean, virtually everything you do, the breathing that you do, the speaking that I'm doing right now and you will do, all of this is enabled, made possible by the skeletal system. Of course, functioning with other organs as well, the muscles and nervous system and so on. But without the bones, something sturdy for those muscles to pull against, you can't stand up, you can't sit up, you can't speak, you can't breathe, you can't do any of the things that we take for granted every day. So support and movement, and I'll give some examples in a moment. Energy and mineral storage. And let's begin here with energy. The bone is a place in which you can store excess fat. Many people would not know that, but if you were to cut into cross-section one of the long bones, one of the things that you'll find in the middle of the shaft of a long bone is what we call yellow bone marrow. And basically all that yellow bone marrow is a bunch of adipocytes. Those are the cells that store lipid. And it's just a place in which you can store excess fat for use later when you need it. And it's not just energy that's used by the skeletal system, but it's used by the entire body. So it's a dynamic storage system for fat. As well as other minerals, or as well as minerals. And so we'll see in a moment just quickly about calcium, but calcium and phosphorus mainly are the two minerals that are stored in bone, and both stored and released in a dynamic fashion, in a homeostatic fashion, and I'll show you that. And then also, you may not know this, but the bones are a source for blood cell production. Not only do bones often have yellow bone marrow, but they also have red bone marrow. And red bone marrow are sites for cell production, blood cell production. And this includes red blood cells, white blood cells, and platelets. And so virtually all of the formed elements in blood, and we'll learn more about blood later in this class, can be produced by the bones. It's not the only place in the body that produces new blood cells, but certainly a very important one. So as we look, I want to begin with protection of organs, and I just chose to look at the thoracic cavity. There's lots of places we could have chosen. Of course, I mentioned the cranium earlier, but I want you to take a look at the thoracic cavity because it's brilliantly protected by the rib cage, and here with the sternum and so on. But if you just look within that thoracic cavity, you find some interesting features, and some of these are actually not even in the thoracic cavity, but they are also protected by the bottom part of the rib cage, even though they're in the abdominopelvic cavity or the abdominal cavity. But let's take a quick look. I mean, this brown structure right here is the heart. And that is enclosed, of course, in this rib cage, which protects it both on the anterior and the posterior side, as well as the cranial and the cranial side. So basically, it's surrounded by this bony cage which protects it. The lungs, of course, are the same. These blue things here are lungs, and this purple here back here is lung. This is the spleen, and even though the spleen is in the abdominal cavity, now I've dissected out the diaphragm, and if you remember that the diaphragm separates the abdominal cavity from the thoracic cavity, but because I've pulled it away here, you can see both. And the spleen here is tucked up under the under the protection of the rib cage, even though it's in the abdominal cavity. Also, part of the stomach is as well. Part of the stomach is also protected by that. So anyway, you get a good sense here that the rib cage is a protector of the organs that lie beneath it. Okay, so the next function is to look at the skeletal system's ability to support movement. So as I move to this illustration, I think it demonstrates a little bit more clearly. Here you can see a muscle known as the biceps brachii. This is basically the muscle that allows you to bring your hand closer to the midline of the body, or bring the forearm closer to the midline of the body. Up here you can see it originates on two different portions of the scapula. This is the scapula, a bone you're going to learn about in this module of the class. Here are the two tendons that form or that connect to that bone and then bring you out to the belly of the muscle. There's two different portions of it. And then here's the big belly of the biceps brachii. And then here it inserts onto the radial tuberosity. And what it does is essentially shorten that muscle, and by shortening the muscle, contraction shortens the length of this muscle. That simply brings this bone closer to the midline, and that's what allows you to lift a dumbbell if you were doing curls. And so, just as this is just an example, of course, but there are many bones and muscles that act together to provide movement. This is the triceps here on the back that does the opposite. When you shorten this, it pulls the forearm down and straightens the arm. So these two are working with one another. One to bring the forearm closer to the body, the other to pull it back away from the body. So just as an example, we'll talk more about this when we do the muscular system later on. Okay, and one additional function of the skeletal system is production of blood cells and the storage of fat. And I've mentioned this a little bit earlier, but I wanted just to show you here is the section of the femur, the head of the femur cut open, and you can see that in the shaft you will find this yellow bone marrow, and this is just storage of fat. And here, when you look at the cross section or the transection here of the head of the femur, you can see all of the red bone marrow, and this red bone marrow is the production of blood cells. And I just have one more piece to add, and that is that the skeletal system is also functioning in the homeostasis of minerals such as calcium, and this is just this particular example. But remember, we talked about homeostasis early in this class in Chapter 1. Said it's a very common theme for physiology, and here is a great example of it. If you look at the blood calcium level, it typically is about 10 milligrams for every 100 milliliters of your blood. That's normal. That's the level we should be hovering around. If you've had a rich meal of calcium, something that has just a lot of calcium in it, what will happen is once your intestines digest and bring that material into the bloodstream, you'll have a rising blood calcium level. And that's a good thing. It just means you've taken on a big meal of calcium, and that can be used later. So what happens is your thyroid senses this increase in the calcium level and releases a hormone known as calcitonin. And calcitonin then acts in two places. One, it acts on the kidney to say, listen, at this point, you don't need to be uptaking additional calcium. And you then may urinate more calcium out at that point just because there's an excess. But the other important piece is the calcitonin also acts on bones. And in a process we'll talk about later in the endocrine area of the class. And a little bit more I will talk about as we talk about the building of bone, how this works. There are cells in your bone that are then going to begin to deposit this excess calcium into your bones. Basically store the excess calcium that you've taken on in this meal into your bone. And then because of that, the blood levels of calcium will begin to come back down to normal. So this basically says additional calcium, put it into your bones, and that will bring the calcium levels back to normal. If, on the other hand, your blood levels begin to fall, if your calcium levels begin to fall in your blood, and that can be extremely dangerous. If you have low calcium levels in your blood, number one, your muscles don't contract. Number two, your nerve fibers will not continue to fire and transmit signals. It's a very deadly thing to be low on calcium. So when you have a falling calcium level, your parathyroid glands within the thyroid begin to produce parathyroid hormone. And this parathyroid hormone, PTH, parathyroid hormone, acts immediately on your bone to say, hey, we need calcium. And so it begins to release calcium from the bone matrix back into the blood to elevate the blood level and bring it back to normal. This is a critical portion here. If you've gone a long time without a good meal of calcium, your calcium levels in your blood are going to fall. And when they do, you're going to rescue that via taking that calcium back out of your bones. So very important homeostatic process. That brings me here to the end of section 6.1 in the chapter. So go back and review those functions and be ready on the exam to talk about and give examples of the major functions of the skeletal system.